To find the length of a line, or the distance between 2 points, there's a couple of things that you can do. In this slide, you see that we are just dealing with horizontal and vertical lines. So here's 2 horizontal lines, here is a vertical line. Well, if we want to find the length of DF, when it's horizontal or vertical, you can just count. So if I start here, where we see point D, and I just count over to F, that's 1 unit, 2, 3, 4 units. So very easily, I can see that DF is 4 units. Same thing for RT. So if I start here at R and I count over 1 unit, 2, 3, 4. Again, I see that RT is 4 units. And then HJ, is it going to be 4 again? Here's H, down 1, 2, 3, 4. And sure enough, we see that HJ is also 4 units. When the line isn't horizontal or vertical, you're going to have to use the distance formula. So if we wanted to find the length of RD, which you can see I've already marked it here, RD, and I've also written down the ordered pairs for R and D. The only way that you can find the distance or the length from R to D is to use the distance formula. So what I'm going to do is I'm going to go ahead and just start plugging in the values to the formula. Now if you really want to, you can label your x1, y1, x2, y2 if that helps you. And then just go ahead and start plugging the numbers in. So we get 2 minus a negative 3. Now remember that when you subtract a negative, it's going to turn to a plus. So because this is a negative 3 and this is a minus sign, this becomes a plus. And then we have the plus sign and y2, which is 1, minus y1, which is 4. Now I put my exponent and I just move on to order of operations. So of course I want to evaluate what's inside the parentheses first. So 2 plus 3, put my square root symbol. 2 plus 3 is 5, so I have 5 squared, plus 1 minus 4, which is negative 3. So I just continue to use the parentheses there just to remind myself that I'm dealing with this negative number. And then you can evaluate the exponents. So 5 squared is 25. And remember that when you square a negative, you get a positive, so 25 plus 9. And the last thing that you will do after adding, you get 34. The last thing you will do is the square root. Now because square root of 34 is not a perfect square, the only thing you could do is try to simplify it or use a calculator to get the decimal. Square root of 34 cannot be simplified, and so if you really wanted to use a calculator, you could approximate it. Square root of 34 is about 5.8. The next problem, we're doing the same thing using the distance formula, but this time we want to find the length of FJ. So again, you can see that I drew myself a picture, F to J, and I wrote down the ordered pairs for F and J. And so now you can go ahead and just plug those values into the distance formula. What I would do right now is try to do this on your own, pause the video, and then come back and see if you've done it correctly. So right now, all I'm doing is plugging in x1, y1, and x2, y2 to the formula. And let's see, hopefully I've done it correctly. We've got the x2 minus x1, so negative 3 minus 6 squared, plus y2 minus y1, so negative 7 minus 1 squared. Next I want to evaluate the parentheses. So we have negative 3 minus 6, which is negative 9 squared, and negative 7 minus 1, which is negative 8 squared. Next step is to do the powers, or the exponents. So negative 9 squared is 81, plus negative 8 squared is 64. And then if I add 81 plus 64, we get 145. And again, similar to the last problem that we just did, square root of 145 is not a perfect square. So if I wanted to estimate it, on your calculator, square root of 145 is about 12.04.